Throw a ball at the sky. Gravity drags it back. Every ball, every arm, every time. In 1998, two rival teams of astronomers played that game with the entire universe. It has been flying apart since the Big Bang. All that stuff pulling on all that stuff should slow the flight. Both got the same impossible answer. The expansion is not slowing down. It is speeding up. Nobody threw it. There is no up, and something has its foot on the accelerator. So the universe's story has an ending, and there are 4 known ways it could go. This film interrogates all 4. Fair warning, the verdict got appealed while we were filming. One boundary first. This is not prophecy. It is a forecast. Built from 13.8 billion years of evidence, the universe already mailed us. We take the suspects in order of drama. The quiet favourite and the journey it promises comes last. Chapter 1. The Rip. But first, tools. You cannot interrogate an ending without the universe's driving record. How fast was it expanding at every age? Speed is easy. As space stretches, light crossing it stretches too. Redder light means a longer trip through growing space. Distance takes a trick. Certain white dwarf stars explode with almost the same true brightness every time. Same bulb, known wattage. So dimness becomes distance. The fainter the flash, the farther the galaxy. Astronomers spend careers checking that wattage. It holds. The teams read those flashes across billions of years. The deepest came back too faint. The galaxies had drifted farther than gravity allows. The record, for billions of years the expansion slowed, like the ball should. Then, about 6 billion years ago, it stepped on the gas.
If space itself is stretching, why aren't we stretching? Why isn't the gap between me and my chair getting wider?
Because expansion is gentle and glue wins. Electricity holds your atoms. Gravity holds planets, stars, and whole galaxies tight. It only wins in the deep empties between galaxy neighborhoods where nothing holds on. Your chair is safe. Your galaxy too. Then came the accounting scandal. Add up everything that shines. Stars, planets, gas, you. 5% of the universe. Unseen heavy stuff, dark matter, holds galaxies together. 27% more. The last 68% is whatever presses the accelerator. Science calls it dark energy, not an answer, a label on an open case file. Now we can read the first suspect's plan. The big rip, the ending where dark energy grows stronger as space grows. Stronger push makes more space. More space makes stronger push. It feeds on itself, and expansion stops being gentle. Watch the sky run it. First, the push unbinds the largest, loosest things. Galaxy clusters, whole neighborhoods waving each other goodbye. Ages later, it reaches into our galaxy and flicks the stars away, one by one. The night sky quietly empties. Then it comes home. In the final months, planets slide out of their orbits and drift away from their suns. And in the last fraction of a second, it wins inside you. Molecules, then atoms, torn open. Everything ends everywhere, on an actual, computable date. Notice the order. The weakest grips fail first, the strongest glue holds longest. The rip works from the outside in. Now the interrogation. Every version of this suspect leaves the same fingerprint. Dark energy already measuring stronger than steady. Decades of data say it does not. Stamp it. Unlikely. The show-off talks big. The measurements do not back it up. One down, the next suspect demands the exact opposite. Chapter 2. The Crunch. Here is a secret. For most of a century, this was the favourite. Astronomers argued one question. Is there enough gravity to win? In that story, the universe is a ball still rising. Gravity slows it, stops it, and pulls everything home. The 1998 speed-up benched the crunch, but it left one door open. If dark energy fades with time or flips sides and starts pulling, gravity finally collects its debt. And the schedule? Even the eager versions of this suspect measure the fade in tens of billions of years, patient as apocalypses go. The reversal would start in silence. Expansion coasts, stalls, and the light of the farthest galaxies slowly shifts from stretched to squeezed. The sky itself announces the turn. Then everything runs home. The sky crowds and brightens, and galaxies begin to merge. And it heats. Squeezing space squeezes its ancient leftover glow, warming the whole sky at once. Near the end, the sky glows hotter than the stars themselves. Suns dissolve into the glare like ice in warm water. In the last stretch, the heat unbinds matter itself, atoms dissolving not by stretching, but by fire. The rip's destination reached by the opposite road, until it finishes the way everything started. Everything, everywhere, one hot point. And after that, honestly, nobody knows. But underline this suspect's entry fee. It needs dark energy to fade. Remember that sentence. Keep this card close. 2 suspects, 2 opposite demands on dark energy. The third suspect could not care less about dark energy. Chapter 3. The Decay. Empty space has settings, and ours might not be the deepest. Like water chilled below freezing, still liquid, one tap from snapping to ice. This is not idle imagination. When physicists measured the Higgs, the field that gives particles their mass, the numbers landed near a border. On one side of that border, space is settled forever. On the other, it is supercooled water. We appear to sit close to the line, on the almost settled side. If any point of space ever snaps to its deeper setting, a bubble of new physics blooms, spreading at the speed of light. No warning is possible. Nothing outruns light. Inside, new rules. Chemistry breaks. Atoms fail. Us? Also atoms. And unlike the first 2 suspects, this one leaves no fingerprint in advance. There is nothing to measure coming. It can only be ranked by theory.
A bubble that could start anywhere, at any moment, with no possible warning. Why is anyone calm about this?
2 answers, both calculated. First, the odds. The expected wait is so long, it makes every other number in this film look like a rounding error. Second, the getaway car. Expansion accelerates, so the distant deep recedes faster than light can chase. A bubble born too far away can never reach us. And all of it assumes physics has no missing pieces, which would be a first. Stamp it. Possible. Absurdly rare. The trapdoor is real, and it practically never opens. 3 cards stamped, and every one of them demanded drama. Strengthen, fade, snap. The last suspect needs nothing at all. Chapter 4. The freeze. No tearing, no collapse, no bubble. Dark energy just keeps doing what it is doing. That is the whole plot. No new physics, no dramatic date, just patience. And patience, it turns out, is the strongest suspect. Here is how we checked. The early universe left us a ruler. When everything was glowing plasma, pressure waves rippled through it like sound. Space cleared, the ripples froze mid-stride. Ever since, galaxies faintly prefer one particular spacing, a ruler stamped into every age, stretching with space.
Every clue so far is old light, the past. How does any amount of yesterday tell us about forever?
The same way a driving record talks to an insurer. Measure the trend, test it in every era, extend it honestly, and say how sure you are. Since 2021, a telescope in Arizona has aimed 5,000 robotic eyes at that ruler across tens of millions of galaxies. The verdict of 13 billion years of records, dark energy holds steady, within precision. The quiet suspect, the freeze. So here is the sentence, carried out in full. The journey to the end of time. Fast forward. First, the sky forgets its neighbors. Gaps between galaxy groups stretch faster than light can cross. far galaxies redden, fade, and are gone. Our galaxy and its neighbours pull into one last island of stars. Beyond its shores, permanent dark. Now the fuel runs out, and we need a new kind of number. 10 to the 14, a 1 wearing 14 zeros. 10 to the 14 years in, the star-making gas is spent. The smallest red stars sip where our sun gulps, so they outlast everything. Then even they gutter out. The last star in the universe goes dark quietly, mid-nowhere, with no occasion at all. What follows is not empty. Dead suns by the billions cool slowly toward black. Once in a great while, two of them collide, and the dark lights one brief candle. Over even longer spans, the island itself unravels. Close passers fling dead stars into the void, one by one, until the neighborhood is gone. If protons themselves decay, nobody has ever caught one doing it, then even the dead suns eventually dissolve into light and lighter pieces, which leaves the black holes, for an era beyond every era, the warmest things in existence. But even they leak, one faint particle at a time. After 10 to the 100 years, a 1 wearing 100 zeros, the last black hole evaporates. What remains is a thin, even haze, the same everywhere. And sameness is this story's real villain. A campfire warms you because fire and night air disagree. Every star, every engine, every thought runs on disagreements, energy flowing from more to less. Heat death is not cold like winter, it is even. Nothing flows, nothing burns, nothing ticks. The universe simply runs out of happenings. Case closed. Tidy. Until 2024, when the ruler filed a new report. The newest measurements hint that dark energy may be weakening, as if the foot on the accelerator were easing off.
Hold on. If dark energy is fading, isn't that exactly what the crunch card needed?
It is. The crunch card is back within reach, not as the verdict, as a live possibility. But precision matters. This is a lean, not a discovery. It has not cleared the bar science keeps for rewriting the future. So the freeze still leads, and the file stays open. A verdict is the evidence's latest word, never its last. So, how does the universe die? On today's evidence, not with a rip, not with a crunch, not with a snap. A long, calm running down of everything, pending appeal. Remember the ball nobody threw? Still up there, still speeding away. And every telescope we own is watching how its flight ends. If that feels heavy, check the calendar. Squeeze the whole age of stars into 1 year. Everything that has ever happened, every galaxy, every person fits inside the first 90 minutes of January the 1st. It is the universe's first morning. The stars are on. It would be a shame not to look.